but does it really work is the question.
This was built by folks who understand the area that they're coming from.
And their engineers try it out and they're like, wow, did that really just happen? Like, and that's actually a response we've gotten many times.
Welcome to Tech Talks podcast. I'm Jeff Trent, a solutions architect here at Anytime Tech. Today we are welcoming Chris and Oliver from Q-tex AI. Why don't you go ahead and give us an introduction about yourself?
Sure. I'm Chris Dagher, one of the founders of Q-tex AI. I'm also the CEO and CTO.
And I'm Oliver McDonald. I'm the other co-founder, and I am our COO and CMO.
Awesome. Why don't you tell us a little bit about Q-tex AI, maybe your journey, where you guys met maybe, and how the idea formed to get Q-tex AI.
Yeah. Should we start at the beginning with physics?
Sure. Everything starts with physics.
So Chris and I first met a bit over 4 years ago now. It was my sophomore year at Boise State. I walked into the wrong building at Boise State, realized that I was in the wrong class when I should have been in the physics lab and instead was looking at economics, and had to run over to the next building over, with the only seat left open being next to Chris. And then later that day, Chris showed up to a club, or the mechanical engineering club, that I was the vice president of that year. And since then, we've been working together on multiple projects, almost daily at this point. I think, if not, it has been daily at this point.
Yeah, there was a period where I think we probably spent like 10, 12 hours a day, easily, every day, plus weekends, holidays. At one point, we were sleeping in the machine shop at Boise State for like a 3-day weekend. We did that 3 times, I think, in a semester. Yeah.
But yeah, so we got to know each other pretty well at Boise State. And then Chris went on a fun trip before he figured out what he wanted to build for Q-tex.
Well, more or less, yeah. I mean, it was designing a power supply for Bender, a robot that we both worked on. And I had the hardest time finding a MOSFET for a particular application. I needed to switch 50 volts, 60 volts?
60 volts.
60 volts and 50 amps continuously for a hot swap battery application. And it was very hard to find MOSFETs that could fit that need while still being like relatively low cost because student projects. And so I think I exclaimed, and I was probably the only person, I was in my PhD at this time. I was the only person in the lab because it was super late at night. And I exclaimed like, why can't I find this MOSFET? This is insane. And of course, right, I said that to myself because nobody else was there, but I still talk to myself a lot. And so then I kind of just stashed the idea away in the back of my head for a little bit. Fast forward like 3 months, maybe something like that. I quit the lab that I was working in and kind of just hit pause on the PhD for a summer. And I went to go bike across the Adirondack Mountains. So I'm from New York originally. I went back there to bike, just figure out what I wanted to do next. And on the second day, it was cold. It was rainy. I was like sitting in my tent late at night, just hunched over my freeze-dried lasagna. And I was like, you know what? I'm going to go do something completely different with my life and see where this goes. If this is an idea that has legs, then like, yeah, that'd be cool. So I got back to Boise and sent Oliver a text and said, hey, you remember that kind of stupid, crazy idea I had? Let's get a beer and talk about whether or not we should go into business together.
Yeah, and then we got a beer. Ironically enough, when we were getting that beer, we were at Boise Brewing, they're downtown Boise, at the same time they were filming for What Would You Do? So we're there talking about circuit boards, like how we would approach this problem, struggle of finding parts. And there's some odd commotion happening off to my side, and I'm trying not to pay attention to it. I know Chris has no concept of what's happening because he's very into the idea. And next thing I know, I see cameras come out, and so does Chris. And I'm like, oh no, what is this? And then they're like, yeah, you're on What Would You Do and all that fun jazz. And we're all there like, what is happening? the producer was like, yeah, you guys seem just so like involved talking about what the folks next to you were talking about. And I was like, we've been talking about circuit boards for the last like hour. I don't know what's happening. But then from there, we joined the Boise State incubator, or the Venture College's incubator. And that's where we got to start actually working with some companies in the local area. Just Chris, in literally 3 days, put together our first version of the product, our first demo. And we took that to a few different companies. And even with that first demo, one company in town who's been a great champion for us and we're still working with now, within one of the first searches, they're like, wait, you just found something we need? Can you scroll back up so that we can take a screenshot of that? Because that's what we just spent the last like week looking for. And we got more responses like that. So towards the end of, and this was last fall of 2024, we eventually said, okay, hey, there's a lot of people interested in this. We've got more information from the incubator. Let's launch this. And then that's where we are now.
Awesome. Okay. We've talked about what Q-tex does. I want maybe your elevator pitch. What is Q-tex AI? What do you try to solve? What are you doing?
Yeah, so we built an AI co-pilot that helps electrical engineers design circuit boards 10 times faster than they could before.
Awesome.
Yeah, I mean, it's a pretty clear value proposition for engineers and for companies at that point.
So you talked about like finding existing products, on the market to help with that. So, but in your pitch just now, it kind of sounds like you do more than that. Do you like does it design schematics? Does it what else does it do?
So right now it's essentially a datasheet co-pilot.
Okay.
And datasheets, from all of the customer interviews we did, those were kind of the worst part of designing electronics. A lot of different engineers have fun in schematics, and a lot of them have fun in layout and board design. But pretty much nobody that we talked to said, yeah, I really love reading technical data sheets and just pouring through them.
Got it.
So that was the first thing we set out to solve, is how do we get rid of these data sheets? And so our co-pilot has this big database that we had to design, and it can search through millions of data sheets in like a couple of seconds and then pull out relevant information to construct an answer, both for, like, as Oliver said, part recommendation, and like I mentioned when I was trying to find MOSFETs, but also if you want to say like, hey, how do these two parts actually connect together? Like, what does the communication interface look like? What types of connections do they need? What's the operating temperature of this collection of parts? All that kind of stuff. It can do all that because all the information's in the data sheet, and we have a reasoning engine in the back end that can connect all the dots and put it all together.
Okay. I am not like an electrical engineer, so I'm trying to piece this together.
Yeah.
Like 15 years ago, I built a PC, and maybe there's PC part picker. And it's like if I did not have that site, it would have been an impossible task, right? It sounds like what you're building is that for electrical engineering in general. Is that maybe a bit of a okay comparison?
Similar. Think of PC part picker, but if you just typed what you wanted, as if you were talking to a colleague saying, hey, I want to design a computer. I want these specs. I want this operation. I'm using it for these purposes. And then it just says, okay, cool. Here's the CPU you need. Here's the board. Here's your graphics cards, but for components. The big issue we have is there's actually one company we're talking to where they're like, we have somewhere between 1 and 3 billion data sheets in our database.
Oh my gosh.
We think it's about 2, but we've lost count. So they lost about 1 billion data sheets. And it's just because there's that much. And one search for something like a microcontroller, which you can think of as the brain of a circuit, you can do a very simple search and you'll hit about 100 to 200,000 options, each with the average data sheet size of 80 pages, but for microcontrollers can be 500, if not more. So regardless of part, if you have an average of 80 pages per document and you even get a search with 30,000 options, you can't parse that. You can't go through and figure out what's going to be the best for your project. So you typically do what the rest of us do when designing circuits, which is a Hail Mary, pick the ones that look close enough, and then start reading just key points of the data sheet to see what you might want to implement, go buy it, test it, and then go back to the drawing board if it doesn't work. So we want to cut out that process of why are we taking a Hail Mary on new tech when we have technologies that can be used to help us find this information we need. It's already there. We just need a way to get it to our users.
Awesome. Especially when there's highly technical pieces with lots of different things. And if you want a camera attached to your microprocessor. You know, it's like, is it compatible? Does it have the right pins?
Yep.
So
Yep.
this helps
Mm-hmm.
eliminate that. You know,
Yeah.
get rid of the guessing. If
Mm-hmm.
okay, awesome, cool.
Yeah. Another thing it does actually as well is new technology typically takes a couple of years to actually make it into the market.
Right.
And one of the reasons is sort of similar to like what Oliver said, where it's just like, okay, I'm going to select these handful of options and start reading. Another thing that engineers frequently do is just say, okay, forget it. I'm going to use what I already know, right? I'm going to use the same parts from the previous design. And it might work, it might not. But especially with like demand for higher tech products and like more features out of products every year, that doesn't always work. And so frequently you have to use new parts, which takes more time and takes more engineering resources and costs more money.
Yeah, I know of one project similar. You know, firmware embedded, you know, hardware project, I should say. You know, they had a solution for a similar product. They want to make another one instead of like finding a new board. They're like, let's just put another microprocessor in it,
Mm-hmm.
and that can't be the most cost effective way, right?
Not
Like,
at all.
so it's, I think, you know, as you said, you know, there's newer products that are coming into the market that probably can do everything that someone would want. Instead of picking another one, is find maybe a newer product.
Well, so we actually have a story about that.
Yeah.
Even back to our first demos of the first version of our platform, we were sitting with one of the companies who tested it out, and they went off this long list of we need a microcontroller with like 10 different communication. It was 5 communication protocols, but like 10 connections across them all. We were all sitting there laughing like, this doesn't exist. No one has made a part like this. You should be using like 5 components to go make this happen.
Yep.
And then our system gave them a pre-release part that did exactly what they needed.
Wow.
That we didn't even know were on the market because it was, we had a database built with a few different popular manufacturers. And even us, we don't know half of what those chips are just because there's too many for any one engineer to memorize. But then we're like, well, cool. I guess we just found you the part that does exactly what you need, and you don't need 5 different chips to make this happen. So there's the new technology in that regard as well has been pretty interesting of just how do we cut down these number of chips? Because a lot of processes are the same across circuit boards now.
Yep. Yeah, that's awesome. Yeah, I can't imagine the amount of like hours that goes into choosing the part originally and then testing the part to make sure it actually works, and then, you know, that iterative cycle of oh, that one didn't work, let's get another one. You order it, it takes 2 weeks to get there, you know, that process. So yeah, that's awesome. Anything to speed up that process, I'm sure, is a huge saver for so many companies.
And just quickly to add on to that, because we do have this number, it's roughly 60% of research time is spent in the data sheets.
I mean,
So
it's not just
or
research,
not-
a lot of
design actually overall.
yeah, a lot of the design time, up to 60% in some cases, like Oliver said, is just spent reading data sheets.
Yeah.
And not just engineers doing that, like a lot of the different stakeholders. You've got people in procurement, in manufacturing, validation, testing. All of these people have to read data sheets. And so it's like, okay, this is actually a crazy amount of time. Thousands and thousands of hours, tens of thousands of hours is spent just reading data sheets. Like, seriously?
Yeah. I think this is such a cool use case because from my experience of AI, especially LLMs, they make enjoyable thing. You know, they solve the part that the human wants to do. You know, like as a programmer, you know, the AI coding assistant takes the fun out of programming in a lot of ways. I write code faster, but now I'm stuck doing the debugging part, which I don't really want to do. I'd rather be the one writing the code originally. But it sounds like what Q-tex AI is really solving is this part for most engineers, maybe all engineers. They don't want to be looking at those data sheets. They want to be doing the tinkering. They want to be building stuff. So it takes out the painful part for them, makes it go faster, and they can do the stuff that they actually enjoy.
Yep.
Exactly.
Cool. I love hearing when AI can solve those types of problems. So that is so cool. Why don't you take me through kind of your entrepreneur journey? Like you met at BSU, you had this idea. Recently, there was a pitching contest. Sounds like baseball almost. A business pitch contest in Boise, and you won. So maybe you can kind of tell us about that journey.
Okay. So as I said before, we started at the Boise State Venture College. That was in their incubator. That was where we learned how to actually like structure our business, how to start running things and start making those initial decisions of what we wanted to do and then support that. I had come out of, I'd done consulting locally here in town. So I had my very small bit of experience running my own little firm. But outside of that, this was entirely new to the both of us. So there was a lot of questions, a lot of time spent just learning the process. From there, we got pulled into a few different pitches with Boise State, and that turned into in the spring of this year, we competed and won the Hackfort Tech Challenge at Hackfort, I guess. Yeah,
Yeah.
Tree Fort here in Boise. Then we won our track and overall at the Idaho Entrepreneur Challenge as well. And then from there, it was really building up to now pitching at Boise Entrepreneur Week and taking the home prize or the big prize for that, which was the 50K. Throughout all of that, there has been, even from the beginning, nights of just practicing pitches, understanding what our story is, what our threads are that we're weaving through, and really how do we say what we're doing without being technical? Because a lot of it is not many people know what a circuit board is or why it matters or why cutting down this time means they get better technology. And especially in such a tight community here in Boise, you have to be able to talk to both your community as well as those who are technical and make sure both understand what's going on. So as we continue to develop the product, work with other companies, and launch our initial private beta last March, we were also working a lot with the community to actually go out to events, connect with them, understand how we can give back to the community, and really find places to practice talking about tech in non-technical ways. And that, in return, gave us a lot of feedback of how we should work our messaging, what people are interested in when we're talking about our product, and how we can really pull that story through about us building the company, the product, and how we've helped other local founders here in town with their products as well. And from there, we just kept building, worked on the product, worked on getting some traction. We now have our public beta available for anyone to sign up for. And it's just been a matter of working with the community to see the best way to get feedback from them and help put back into the community to be able to see how we can best grow our company here in Boise, but also expand into other areas as well.
Okay, I'll have you share again at the end, but
Yes.
how can people sign up for Q-tex AI?
Yes, so you can go to partwise.qtex.ai, and that will bring you to our actual apps page, and there is just a sign up button. There is also a sign up button on our homepage at qtex.ai, and it's just in the top right corner. We have a base version that's entirely free. You get 50 prompts a month, which can get you a fair bit through designing your first ever circuit board. And it's been built in a way, and this was actually an outcome of how engineers like to work with the product, but it's been built in a way that someone brand new to the system can go in, or brand new to circuit boards, can go in and start asking questions, get help walking through the process, and figure out at least the starts of how they can build their own circuit. Because at this point, and I was talking with a student about this yesterday, actually, you can design your own circuit board and have it sent out for manufacture and back at your own house as your first prototype for 50, 60 bucks, depending on the size. Yeah. So a lot of it is we want to make sure that electronics is accessible, and a lot of the softwares are already free or available. So we want to still meet the hobbyists and those in that community where it is. And then for businesses, we do also have a version where you can have collaborative features and be able to have your team all work together for their products as well.
That's awesome. I didn't even think about that as you shared it, but I think this does enable, entry, or hobby individuals to come in, and that might be an intimidating part. How do I choose the right components for this idea that I have? And to be able to just type in their idea into a AI chat and get like the list of parts that they need. So that is so cool. Maybe let's focus on maybe that idea for a little bit. Like, how have you designed Q-tex AI with like the hobbyist and enterprise in mind? Is it able to handle both in a good way, or are there different features that you've had to implement for different use cases?
Yeah, it's in a lot of ways it's actually the same, which I know sounds kind of ridiculous that enterprise and hobbyists are the same, but engineers kind of work the same way across the board. For enterprise, they don't necessarily want to be told exactly what parts to use. It's more of like guiding them into finding the right parts based on their spec. So we don't want to do the design for them. We don't want to do all of the heavy work for them, but we want to make it easier and faster to find the information and the parts they need. And that's like for enterprise, really the problem that we solve. Make it easier, reduce the friction for engineers to find the parts and the information they need. And that's what most of our like business and enterprise customers are interested in. I mean, pretty much all of them actually. But then on the hobbyist side, hobbyists also really enjoy the process of tinkering and building, and sometimes they just want to be told what parts to use. But frequently, at least for hobbyists that we've talked to in electronics, they want to know why it's the right part, or like, why does this work? And so there are some slight differences in the agent's behavior based on whether the individual is a hobbyist or a professional engineer. But that's really just handled in our chat server based on like the way that the memory and the context is all handled.
Got it. Maybe we can dive in a little bit deeper on the technology now. So it's an LLM. So is it? Maybe not.
It's a mix of things.
Yeah, why don't you go ahead and kind of share, as much as you
Sure.
want. There might be some stuff you don't want to share, and obviously you don't have to, but yeah, I guess what makes Q-tex AI better than me just putting in a bunch of files in like ChatGPT or whatever, and here's some data sheets. What's the best for my use case?
Yeah. We could go into a whole, I mean, we could talk for hours about that, but I mean, really the problem is, let's start with if you just ask ChatGPT, right?
Yeah.
Like you don't give it data sheets, but what if you just ask ChatGPT? It's been trained on stuff like the Electronic Stack Exchange and Reddit and various electronics textbooks. So it knows a lot of common parts, but a lot of times the common parts are not actually the right part, especially for a business where you're trying to save cost or squeeze as much capability into as few parts as possible. The common parts just aren't it.
Might be okay for a hobbyist, but it's not going to give a business competitive advantage.
Exactly. Yeah. And so, yeah, asking ChatGPT, you'll get popular parts or common parts or older parts, but the newer parts it doesn't have because of the knowledge cutoff, whenever that is, right? Depends on the model, but then let's kind of go to the case where you've got a bunch of data sheets and you just give it to the model, you give it to ChatGPT. It's not actually the typical way to search files is RAG, retrieval augmented generation, where it generates a bunch of chunks of the text from the file, turns those into vectors, and then it searches for the most similar vectors to what you asked for. That is a few pitfalls. The first is that the question that the engineer asked might actually not be what they're looking for, and that kind of falls on the context of previous questions. And so you need to consider the previous questions and conversation that they've been having in order to actually form the database query.
And I'm guessing, like these AIs notoriously bad at math.
Yeah.
And a difference in a number for electronics is a big deal.
It is a big deal.
Like 40 volts or for 60 volts or whatever. That might not be a big deal for ChatGPT. Oh, those are both numbers. Those are similar vector space. But
Yeah.
like for designing a circuit board,
Yeah.
problems.
That's a big problem. Yeah. If you put 60 volts into a circuit board that was only designed for 40, odds are it's going to blow up.
Yeah.
Or you'll let the magic smoke out. And believe me, that stuff's really hard to put back in.
Yeah.
But if you just pass, kind of going back to like giving it just a list of data sheets or a bunch of data sheets, it'll just feed that into the context window. It won't vectorize. It won't build a database based on that. It's just going to feed it into the context window. And although LLMs are really good at needle in the haystack problems, right, trying to find like a single word or a single line of text within like a big corpus. I mean, OpenAI loves to publish that whenever they release a new model, right?
Yep.
They're like, yes, we've scored 2% higher, 3% higher on needle in a haystack. Fantastic. That's just frequently not the application because it requires bringing a lot of different pieces of information together and sort of reasoning based on that. So like Oliver said, we've got somewhere between 1 and 3 billion parts that we need to be able to process. That's just too big for a vector database.
Yeah.
Some people would certainly disagree with me, and I welcome the discourse. But for the type of data that we're working with, and for the really critical decisions engineers need to make, a regular vector database just can't do it. So we actually had to design a totally new structure from scratch that could do that. And so that's what we did.
Cool. Maybe kind of share more about some of the times that through the process where Q-tex AI gave you confidently wrong answers, or I think that's a problem with LLMs. ChatGPT is like hallucinations and confidently hallucinating.
Yes.
And I think, as we kind of talked about before, if it confidently tells you no, this 60-volt part is fine in your 40-volt, circuit board, then that's a problem.
Mhm.
So maybe you can kind of go through kind of more of that process and some of the things that you've learned along the way.
Yeah, I think that I'm hesitant to say our system is hallucination proof because I feel like that's a lawsuit waiting to happen.
I will say, if anyone who's designing an LLM says this is hallucination proof,
Yeah.
I immediately am going to say, okay, they're just lying about that, right? Like,
Yeah.
I think it's, I think that especially right now in 2025,
Yeah.
it's an impossibility. Like
Mhm.
LLMs by definition,
Mhm.
they just put words together, right? Like,
Yeah, there is some interesting research from Google DeepMind on using more of the layers from an LLM rather than just like the first layers and the last
Yeah.
layers. If you actually encourage the use of all of the attention layers throughout the model, then the hallucinations do decrease pretty significantly. But that's still really early research. I don't think we'll see that in a Gemini model until like probably sometime in 2026 or 2027 for practical use.
Yeah.
But the best way that we can get around hallucination today is context. And so that's feeding the LLM correct and accurate information that has pretty much everything that it needs in a format that it's able to easily understand. And so that's really what our system does, is it focuses on making sure that it gets the right data sheet to the LLM in the right way at the right time, or the right section of a data sheet, not just necessarily the whole data sheet. But yeah, getting the right information to the LLM at the right time in the right way is really what our system focuses on. And then we also provide citations so that engineers can always look and say, okay, yes, this is correct, or no, this is incorrect. But that's really how we get around the very confidently, very wrong
Yeah.
kind of problem.
Mhm.
Because that's an expensive problem for especially companies, right? When they're spending maybe $100,000 or even tens of thousands of dollars on prototypes, sometimes just on parts, right? Not counting labor. If our system gave them wrong information very confidently, and then they waste $100,000 on that, well, they're probably going to come back to us and say, hey, you owe us for this.
With technology, with AI, what scares you in the next 2 to 3 years? How do you think the world's going to change? I think it's fine for you to be specific in your industry for this question. If you want to answer generally, I think that's also interesting. Afterwards, I'll ask, how do you think it's going to change positively? But previously, I've asked the positive one first, and then ending the podcast on the negative note.
Sure.
It kind of kills the vibe a little bit. So, what do you think's what worries you? What concerns you over the next couple of years in regards to technology?
Do you want to go first, or should I?
And I'm going to give you a hint. If you can bring in how Q-tex AI helps solve those problems,
Yeah.
that will
Yo.
make a great answer.
Well, all of my thoughts are very broad scale. Do you have anything like
No, go for it.
Q-tex related? Okay. So there's two parts to what I'm thinking about right now. The first one actually comes from a paper that Chris sent me on AGI and how, with the impact of LLMs on society right now, AGI might only happen to the extent that our understanding of knowledge drops so far due to LLM use that we only think we hit AGI because we, for lack of better words, have made ourselves dumb to understanding what technology can do. And that's a lot of issues. I get to teach a class at Boise State, and that's a lot of issues I see through some of the students where they've come in, they've used AI for different projects for assignments, and when they have to apply knowledge to actual problems, if they don't have ChatGPT, they can't. And even I've noticed this in myself. Chris has seen me at the office with this, where I'm very quick to just throw something at ChatGPT, but I have actually had to pull back because I'm noticing, I'm getting a bit annoyed that a paper is taking me 30 minutes to write, when if I want it to be a good paper, it should be taking me like 3 hours, and I should be prepared for that to make sure it's good. And understanding really why that behavior is changing to why are we getting so used to spending almost little time on something and just sending out whatever AI generated and calling it good enough? And with that, the other one is the dead internet theory, which is we're generating a bunch of AI slop in terms of images, in terms of text. We have Reddit bots just commenting on each other to generate more text. That's just bots screaming at other bots that then get refed into AI systems. And that's just sort of compacting itself. So a little concerned to see how the internet and those sort of social connections start to degrade over the next few years if there aren't any more protections being put into place for that.
I think those go into each other, right? Because
Yeah.
now humans are reading content on the internet, and whether it may be AI written or not, probably is now. It's like it just it devolves, and the people reading that information probably isn't getting smarter. The people writing it aren't writing it in the same way, and I think like yeah, I think that's one of the big things about AI that I'm most concerned about right now. Is the dead internet theory, the regurgitating the AI slop, and then I think what it's doing to the average person of you are what you eat, you are what you consume, and if you're just consuming AI slop, then you get dumber for it. And then I haven't heard that spin on it though. For your first point, that we'll only think of an artificial general intelligence coming about because we get dumber that we think that the AGI is actually an AGI.
Yeah, that was the article. I mean, I really appreciate that article. Actually, it was in I want to say a psychology publication. I forget exactly which one, but it essentially said like, forget AGI, MCI is really what we need to worry about, which is like minimum cognitive integrity, or something like that. And yeah, exactly like Oliver said, we're just going to get dumber until we're at the AI's level, because I don't know, this is actually something I'm very interested in. And if anybody at one of the major AI research labs could tell me, feel free to send me an email. But I'm very curious on how we're going to get super intelligence training only on data from human intelligence, right? Like we've trained basically from all of human knowledge and history. I mean, there was the recent lawsuit against Anthropic where they bought pretty much every book in existence and then just shredded them after they ingested all the data, right? They read all the text and they shredded the books afterwards. I'm very curious how these labs believe genuinely that from human intelligence we will build super intelligence. And it's a skepticism of mine. I'm actually quite an AI skeptic, which is ironic, but
I think there's I think that is so good. I don't know. I wish more people were, right? But the more that you understand it, the more you're like, is it actually going to get there? I think there are, like before we started recording, there's more than just LLMs, of course, right? And I think there's advances in those areas, which I think are promising. I don't think the large language models are going to get us to a super intelligence. However, I think like, neural nets, others escape me. There's other promising AI. AI is a loaded term. And
a huge field.
Huge field, yeah.
I think that's where sort of Q-tex, we were very careful with when saying it was AI, because we have our name Q-tex AI, and then very quickly we were like, why did we put AI in the name of our company? But as we were developing Q-tex, a lot of it was, where do we actually need AI versus where does a traditional algorithm make more sense? Where can we balance it and use AI like the calculator it is? I mean, it's non-deterministic, so it's sort of like a really bad calculator that sort of just guesses what the output is. But where can we use LLMs effectively as the calculator they are in a greater system to create change in some space, rather than relying on that one technology to actually create the change itself? Because there's so many cases of AI where we'll throw stuff at it and it gives us the stupidest response in the world. And we're just like, why do we pay for this? Why has this made so much money when it fails at such common questions sometimes? So
yeah. Yeah, I mean, I think that kind of leads into another point, which is like, there's a lot of talk about an AI bubble.
Yeah.
I believe that we are in an AI bubble. I think that the market, certain parts of the market, are extremely overvalued. For example, an app that's just a wrapper around ChatGPT where you take a picture of your food and it tells you how many calories it estimates that to be. Like, okay, that's literally just a wrapper around ChatGPT. At some point, there's going to be enough people using that OpenAI is just going to say, okay, cool. There's people using that. That's something we do natively, and they're just going to eat this company's lunch. And that's why we build tech to try and like not have that happen. But I think a lot of the AI market is really overvalued in that sense, because the traditional investor, like venture capital investor formula is, okay, tons of users means either tons of ad revenue or tons of future revenue. And so it's speculative at that point. So we're going to dump money into this idea or into this startup because they've got tons and tons of users and people really love the app. But if it's something that can just be replaced in like 30 minutes, right? Like with one update to ChatGPT, like what's the point? So I think that segment of the market, and there are a lot of companies like that, I think that's really overvalued, and that there's going to be a significant loss from that perspective.
I mean, you look at the .com,
Yeah.
bubble and bust, right? Like, because .com, because it burst, we don't think the internet was valueless, right? No, the internet's very valuable, and I think everyone would agree. But just because I had dog.com doesn't make whatever product I'm selling actually valuable.
I'm pretty sure the URL is probably more valuable than the actual product.
Right. And I think that's what you saw a lot in the late 90s and stuff like that, is you get a valuable domain. And then once again, search engines really became powerful. And it doesn't matter what your domain name is, because people aren't putting in dog.com to find things about dogs. They search, Google or whatever. So yeah, I think something similar is going to happen. I think, it sounds like your product is, something that's actually valuable. It it solves a problem that people have. It can save a lot of time and money for engineers that get paid a lot of money, right? Like
yeah, I mean, in a certain way, right? And we've talked about this a lot internally. Like, one of our competitive advantages from like a product standpoint is that nobody cares. Right? Like, engineers are a niche. And like, how many companies are there? Like, how many commercial software companies are there that make engineering software? Well, there's Autodesk, there's Siemens, there's PTC, there's Altium. I mean, I can list a lot, but we're not talking like consumer brands. We're talking about like a handful of really big companies that are generally very slow moving, slow to adopt technology, new technologies, broadly speaking. And like, these companies, although they're very valuable, they deliver value to engineers, they're not delivering like the newest value to engineers.
I mean, we joke internally, a lot of the softwares we use and have used, because Chris and I both did product development professionally before this, our softwares look like they came from the 80s. There was one software that is one of the major suppliers for Datasheets, and the software legitimately looks like something you would create on like Windows, not even Windows XP.
It looked like Windows XP.
Yeah, it was.
Well, like, not to call out analog devices, but LT Spice, if anybody's used that lately, right? I mean, one of my students was asking me about it the other day, and I was like, yeah, no, this software, the user interface is horrible, but there's a bunch of engineers who are like 60, 70 who know LT Spice from like Windows XP, Windows XP really. And so
I mean, don't look at me. I've been learning Vim, so like
honestly, Vim has a better interface than what we use at this rate.
Yes.
So.
Yeah. So yes.
But yeah, there's very little like development in our space.
Yeah.
There's been a few AI companies on like the greater design side of circuit boards that have been that came out about 5 years ago, and then everything sort of dropped off. Before them, it was about a decade and a half since the last major products hit the market. And,
so, I guess the next question here is, how do you build trust? There's these big companies. Sure, they're slow, but they have, probably account managers assigned to all the other big engineering firms. And now you're this little guy coming in, and you're like, hey, we have this product. It can revolutionize the way that you guys do business. You pay your engineers 6-figure salaries, and we can cut the time that they do stuff in half, and they can focus on what they're actually good at instead of this busy work stuff that they have to do.
Yeah.
So, it sounds like a great pitch, right? But how do you build trust for these big companies to actually, once again, if they're smart, they're an AI skeptic, and they're going to look at it and be like, I don't know. Can I actually trust what it tells me? So yeah, maybe I'm sure you've thought about this a lot.
Yes.
So
Yeah, I mean, we do demos,
yeah,
right? We have I mean, enterprise software, commercial software has relatively long sales cycles. And so we do a lot of demos. We sit down with engineers, we sit down with leadership. Um, we meet with them as much as they want to really convince them of what we're doing. Because like you said, the sales pitch is really compelling to them. Okay, yeah, we can cut the time in half. That's fantastic. But does it really work is the
Yep.
question. And so we frequently need to talk through parts of the technology with them. We frequently need to do demos to show them like, hey, this actually does work. And their engineers try it out and they're like, wow, did that really just happen? Like, and that's actually a response we've gotten many times. And so like typically that's what does it. Because like we really do solve such a burning problem for a lot of companies that they're willing to ditch the legacy tools that they pay many times like 6 figures for or more. They're willing to ditch those to just try out our stuff because it's costing them so much money to stay with those tools.
yeah,
And the point to touch on there that Chris brought up was it's doing demos with the engineers, being there with them, having them sitting across from one of us where we've worked in the field. We know the problems because we dealt with the problem. So when we're talking about different parts, different things, there's not just banter about the product, but about the problem and the product that they're developing and saying, oh, as you're walking through these questions, have you thought about these different things? And showing them that this was built by folks who understand the area that they're coming from. And then working with them with the demos to say, okay, what did you just do? What does that look like in this system? I had a student I was working with yesterday who has technically been signed up for the product for like a month now, but forgot he had the product. So he's sitting there talking to me about the circuit board he designed. I'm like, what? Have you used like our system part-wise? And he's like, well, I forgot I had access to that. And I'm like, okay, pull it up. Let's sit down and walk through this. And I was like, just pull up what part you've got, like ask it questions about what you were designing. And he's like, okay. Oh, wait, that's correct. I had this one question that took me a few hours to find. He asked that, and it gave him the right answer. And he's like, that took me like 4 hours to find. So we went through a few of those, and that was really when it clicked for him, when he was seeing the stuff that he had just validated himself show up correctly on the system. That final verification of like, oh, I know these are in effect correct, and the system is giving me that already based off of what I already designed. So now for the next board that he's working on his improvements, he's using it more to go into that process.
cool. Okay, I'm gonna ask this question. I think you kind of answered it already, but it sounds like from the student already had some components and maybe needed more components. So is this something you can do with your system? Is it's like, oh, I already have this microcontroller and these things, and I want to add this functionality. What do I need to get to do that?
Yeah. So it can analyze the list of parts within a design already. And from that, it can say like, okay, will the new functionality you want to build fit into the current parts? Or do we need to add something else? Do we need to replace a part? Like it can actually kind of think through. It's not an engineer. It's not a replacement for an engineer. It's really an augmenting tool, but it can help with speeding up the process of figuring out what the next step is and whether or not you need a new part, add a part, replace a part, or you can just fit it into what you already have.
Cool. Okay. A little bit ago, I asked, what are you skeptical? What are you concerned about? Okay, so here's the flip part of this question now. What are you excited for over the next few years? What's happening in the technology space that you guys are working in, or just generally that you're excited about, you're optimistic for?
Oh God, I'm such a pessimist.
I think the big thing in our space that I'm honestly excited for is that over the next few years, at some point, hardware is going to be making a comeback to the space. Not necessarily because there's capital there, but we're getting to the point where our software is being limited by hardware. So people are being forced back to, hey, we need to start building this again. And that's part of the fun. And where we started as engineers designing hardware and the software with it. And now as there's a focus shifting back towards hardware, seeing more of these new companies come out and these new physical products paired with software. Because software is great, but when you've got products like, I've been playing around with Base 44 for like app development, when they can give me a UI that I can then take and throw to ChatGPT to fix the heinous amount of security issues I got from that system, there's not the innovation on like web app and the software side. a lot of that, like you were saying towards the beginning, the fun's been taken out of that.
Yep.
But with hardware, when you're physically having to assemble something, test it, see how it works, write the software for it, and test all those systems together, I'm very excited to see that come back into play a lot more than it has, as we had a big spike a lot towards that internet bubble as we were building the infrastructure. Then capital shifted very heavily to software, and now it's starting a little bit to shift back. And I'm excited to see that shift continue.
Yeah, I think kind of similar to what Oliver said, I'm really excited for like future hardware. I will say I'm not going to buy whatever hardware product OpenAI releases next. Like they acquired Joni Ives' startup. I'm not going to buy whatever that thing is. I'm not an early adopter typically, but I think that the new ways that people are interacting with software and with products is going to bring in a new wave of really interesting hardware products and a lot of innovation. So I'm very excited to see that and kind of what the products and the different ideas look like. And of course, a lot of them are going to fail, but we're going to see a lot of interesting stuff, I think.
I think with like Gen Z and Gen Alpha, with that, we're seeing a trend towards like specialized devices again. You know, I read an article where like a lot of like Gen Z and Gen Alpha are like ditching smartphones for playing music. They're buying like MP3 players instead because they want to be disconnected from the Doom device in their pocket.
Yeah.
I joke with my wife all the time is like when she's doom scrolling, I'm like, did you find Doom when you were doom scrolling? You know, like
Yeah.
and yeah, I think that's a really interesting point, a really positive point is I think the younger generation is definitely recognizing specialized devices are great. And I once again, I found my old iPod Nano that I bought like 20 years ago, and unfortunately it's broken. But I tried so hard to get it working for my 7-year-old son. You know, I like it, and it's such a fun, nice little device. You know, like I feel like there's definitely a magic with how devices were made 20 plus years ago, and it's lost. So. You know, it's just the phone, the little rectangle of doom in your pocket that does everything. So
Yeah.
And that's really where Q-tex comes into play, is working, because our target customers are startups, small to medium-sized businesses, and even hobbyists developing open source hardware. We want to be there working with them and helping them get their products out, because even we have a blast working with the few companies that we get to right now, seeing their products develop, because on top of getting to actually have the software help them with their product, because we're a small team right now, we get to work with them as well. And we'll get pings like, hey, look at what we developed next, and look at where our hardware has gone because of what you've worked on. And hardware is just always fun to see develop and see where it goes. And it's fun getting to be in a space where we can help folks in that area, and also sort of selfishly build the product that we need so that we can develop hardware again at some point without pulling our hair out on Datasheets. So
Yeah. I think like one interaction we had with a customer that really made me just like feel awesome was I got a text saying, hey, we've been looking for this IMU. It needs to be like really rugged, have CAN bus, all this stuff. And they were able to find it. They spent like 3 days looking for it. And then I was like, well, have you used Partwise? Have you tried out our agent to try and find this? And 30 seconds later, they gave me like a facepalm emoji and said, yeah, we found it. Thanks.
awesome.
And I think they ordered like a couple of samples like that same day. So that really made me feel good. Like, yeah, okay. As soon as it's the challenge really there is showing people that there's a new way to find the stuff they need, right? The parts or the information, whatever it is. But I think that's with our existing customers, that's happening. And I think as we gain some more, like we have some more back and forth with them, we can do some case studies and some white papers, and then new customers will probably more quickly adopt the new way of doing it that we're introducing.
A lot of it is we're changing the entire work process for the start of this design. So that takes time. And that's why we've made it as easy as possible for folks to sign up to start using the system, have enough prompts in the free version that they can actually design something and work through that process. Because we want to, at the end of the day, we want to help them design. We aren't just a company trying to grow big and have a product that we make a lot of money off of. We are a company that we want to build a community around our product and support an already existing community that's been struggling for a few years, because that's the community we grew up in and the community we want to continue support both here in Boise and the greater Idaho area, and then across our other sister states, and then beyond that.
Awesome. Thanks, Chris. Thanks, Oliver.
Thank you.
Thanks for
Thank you.
coming. Why don't you tell the listeners again where they can try it out?
Sure. You can go to Q-tex, Q-tex.ai, and there's a sign up button there so you can try it out for free.
Cool.
Perfect. Thank you.
Okay.
Thanks.
Thanks for watching this In Time Tech podcast. If you'd like to learn more about what we can offer you, please visit our website, intimetech.com, where you'll be able to see the different capabilities and technologies we could provide you in your business. Also, don't forget to subscribe and follow us to get more amazing content like this. Thanks again, and we'll see you next time.